Okay, in this section, we're going to be taking a look at the properties of logarithms, specifically the product rule, which allows us to take a product, a log of a product, and expand it into a sum. And we can use this product rule not only to expand, but we can also use it going back the other way. That would be if they give us this expanded sum, then we know that it came from a product. So that's one of the rules that you're going to memorize. A product becomes a sum in its expanded form, and you can condense it back into the product if the directions indicate for you to do that. Likewise, we have the quotient rule, and the quotient rule says that if you're presented with the log of a quotient, you can expand it into a difference. This rule can also be used going back the other way, so that if you're presented with the difference, you can go back to the quotient. So you can use it going to expand or to condense. Okay, third new rule in this section is the power rule for logs. So if you see log of an augment and it has a power on it, that power becomes the coefficient, as stated here. So this is what it looks like in its expanded form. And when you expand it, you're just bringing the power down in front of the log as a coefficient, at which point the power on the augment becomes 1. While we're going through these rules and doing examples that allow us to practice the product, quotient, and power rule, we're also not going to forget the rules that we learned in the previous section. This rule was presented that the log of 1, any base, is equal to 0. So sometimes that will come about as we're simplifying, expanding, condensing, any of these problems. These properties can be presented, and we need to act upon those properties, again, using what we learned in the previous section. This is the inverse property, probably the property that gets used the most often. So very important to recognize that whenever it's happening. Here it is, the inverse property using a power or an exponent of 1. And basically the inverse property just says that when the augment, that's the number out in front of the word log, is the same as the base, that's this number hanging down here, if those match, then whatever this power is, that is what this entire expression simplifies to be. You can state that in that same inverse property in a more general sense. In other words, not using a 1, but using any exponent. That if the augment matches the base, whatever this power is, that is what this entire expression simplifies to. So that's probably the property that you will be using the most. Okay, so let's take a look at these examples. In the first 9 examples, we are going to be using the product, quotient, and power rule in order to expand a certain problem, the problems that you've been given. And then in numbers 10 through the end, we're going to be using those same properties, but to condense. In other words, go back the other way. So let's look at number 1. Again, you can just keep looking at these rules that are in this yellow box up above. Notice that this is a product, so we're using the product rule. The directions here say use the properties of logarithms to expand the expression as much as possible. Where possible, evaluate the logarithmic expression without using a calculator. That pretty much refers to that inverse property that will allow you to simplify certain terms that come about as you expand or condense. Okay, so the product rule says that when you expand a product, you expand it as a sum. So it's going to be log of 9 base 3 plus log of 7 base 3. So when this comment was made, where possible, evaluate. That means where possible, simplify. So like for instance, this 9 that you're seeing right here, you could definitely use the inverse property because this 9 can be rewritten as log of 3 squared. And in doing so, you make the augment match the base. So you have the inverse property right here. This augment matches the base, and therefore this entire expression is equal to whatever the power is. Okay, here for this term you can't do anything, so you're just going to have to continue to write it as log of 7 base 3. But as I stated, this first term is equal to 2, and then log of 7 base 3. So that is your final answer for number 1. Okay, so you're going to see a lot of that sort of thing, that one of the terms you might be able to rewrite it in order to get the inverse property to be part of your simplification process. Okay, coming to this next problem, again, you have a product, only part of it is a variable this time, but not working the problem any different. You're always going to take apart a product as a sum, just like it says right here, that a product of any kind, whether they're variables or numbers, gets expanded into the terms of a sum. However many factors there are, like here there's 2 factors, there's an x and a y, 2 things that are being multiplied, then you'll have 2 terms in your expansion. If you have 3 items in your 3 factors, then you'll have 3 terms in your expansion. Okay, so 343x is going to be, we're going to separate this into 343 and an x. So we're going to have 2 terms in our expansion. We're going to have the log of 343, base 7, whatever base you start with, that's what the bases of all the individual terms. And then we have log of x, base 7. This, you're going to want to check that in your calculator because possibly you can rewrite 343 as 7 to some power, and if you can do that, you can use the inverse property. So now everyone's pretty familiar with 7 squared is 49. It might be possibly some power higher than that, so let's just check that out. 7 raised to the 3rd power, there it is right there. So that 343 can be written like this. 7 to the 3rd. Meanwhile, the base is the same thing. It's a 7. And when the augment matches the base, those cancel, take the log with it, and this entire expression is equal to whatever is in the power position. So that's going to be equal to 3. This you cannot simplify any further, so you'll just write it as is in your final answer. But this first term simplifies to 3, while the second term stays as is. Log of x, base 7, that's the final answer. Okay, in number 3, we see a quotient being given, and so we're going to apply the quotient property. Quotient property says that if it starts off as a quotient, it expands as a difference. And always after the minus sign will be the term that's in the bottom. That's going to be true even when you're going back the other way with that property. So this gets broken down, this quotient, as log of the top minus log of the bottom. The base here is 4 for every single term because the quotient started off with a base of 4. Okay, now we're going to see if we can possibly rewrite these as 4 to some power, because if you can, then you can go further with this problem. You can simplify these terms further. So right here, 4 to the 3rd is 64 with a base of 4, and this is the same as 4 to the 1st degree with a base of 4. So you can do some further simplifying there. This first term simplifies to 3 by way of the inverse property. That is when the augment matches the base, they take each other out with the log. This second term simplifies to 1. Again, with that same inverse property, that entire term simplifies to 1, and therefore your overall answer is 2. Okay, moving on to number 4. Number 4, same thing, it's a quotient. You're going to take it apart by going log, just happens to be natural log this time. Natural log always has a base of e, the number e, 2.72. So it's natural log of the numerator minus natural log of the denominator. Okay, then you're going to continue to see if you can simplify further. Right here you have the inverse property working because the only base that can possibly be for natural log is e. Since the augment matches the base, they take each other out. This term simplifies to 8. Okay, here you also have ln of e base 13. However, the inverse property does not apply on this term because the augment doesn't match the base. So that is your final answer. 8 minus ln of 13 base e. Okay, in the next one is an example of the power property. You have an augment raised to a power, and so what we're going to be applying right now is the power rule. And all that says is that that power comes down and becomes a coefficient when you write it in its expanded form. The augment will stay where it is, and that power will simply come right in front of the log, acting as a coefficient. Okay, so in this particular problem, bring this down. You will no longer have power 4. That x will become power 1 as you apply the power rule. So now it's a coefficient, and then you just have log of x, and then whatever base they've given you, base t in this particular case. Okay, moving to number 6. You're also going to be using the power rule, trying to recognize that several of the problems in each section have required you to go from a radical type term into a power term. So that's really important that you understand how to rewrite anything that's in radical form in power form, or in other words, exponential form. So this can be written like this. ln, there is 1x underneath this radical. So if you want to write this in purely power form or exponential form, that exponent will be a fraction. It'll be 1. That's how many x's there are underneath there, over whatever the index is. So now it's in power form, and because it's in power form and it's a log, you can use the power rule. And that rule just says that the power becomes a coefficient, leaving that x with first degree. So it's 1/13 now acting as a coefficient times the natural log of x. And you don't have to write the e there. When nothing is written there, we know that it's the one and only base that can exist for natural logs, which is e, so it's not mandatory that you write that. Okay, moving to the second page. Okay, we're still in the problems 1 through 9. Those are all expansion problems. They're already in their condensed form, where it's just a single log. When you're in expanded form, you see the word log multiple times. So here, now we're starting to mix the properties together. The first thing you're going to want to do is take apart this product, and then you'll act upon the power after that. So this is the same thing as log of the first term, which is log of y to the 5th, plus log of z. Okay, both of these are base b. And then as soon as you take apart the product, then notice that one of them, you're never going to leave any of your terms when you're being asked to expand it. Don't leave any of your terms with a power any higher than 1. So you want to apply that power rule when possible. Bring the power down. It'll become a coefficient so that your final answer will be 5. As you bring that 5 down as a coefficient, times log of y base b, plus This term is fine because it already has a power of 1 base b, and that's your final answer. You've expanded that as much as possible. Moving on to number 8. This is a quotient, so the first thing you're going to want to do is take that quotient apart. A quotient gets taken apart, or in other words, expanded, by writing it as a difference. So it's log of the top, and this is base 5, minus log of the bottom, which is x to the 1/5. And there's a couple of things that you can still do here in order to simplify this further. Like you can write the first term in a way that will allow you to apply the inverse property. That 125 can be written as 5 to the 3rd, and therefore the inverse property applies because the augment matches the base, takes this with it, so that this first term is equivalent to just 3. Over here, you're going to be expected to, again, to understand, especially when you have the opportunity to apply the power rule, it's important that you're able to identify the power. So this, in power form, would be x to the 1/5. That expression occurs one time underneath the radical. The index is said to be 2. So this is written in power form as x plus 5 to the 1/2 power. Since that power is anything other than 1, you will apply the power rule, bringing it down in front of the log, acting now as the coefficient. Okay, and number 9, our last expansion problem. Again, we have a quotient, and you're going to take any product or quotient that you get. You're going to take those apart first and then see if there's any further properties you can use in the problem. So it's log of the top minus log of the bottom. Both of these are base b. Okay, and then there's other things that you can do here, like you can take apart this product. So when you take apart a product, you take that apart with a plus sign. Quotients get taken apart with a minus sign. Products, which is what I'm looking at right now, get taken apart with plus sign. So it's x squared, log of x squared, plus log of y. Everything with a base b, because that's the base you started with, minus log of z, with base b. Then as you look at the terms that you have now, you see that one of these terms you can still use the power property. So in this particular problem, we actually got to use all 3 of the properties that were introduced in this section. We took apart a quotient with a minus sign. Then we took apart this product with a plus sign. Now we have a power, and you may not leave any of the terms with a power any higher than 1. So we're going to take this power and swing it out as a coefficient, thereby applying the power rule. So final answer, that 2 becomes a coefficient, so it's written out in front of the word log. And then the augment is just x rather than x squared because the 2 is now in front as a coefficient. And all the bases are b. Next term is log of y, which you can do nothing further to. And then the last term is log of z. Okay, anything that has a minus sign when you expand it, that means it used to be a denominator, whereas the things that have positive coefficients are part of the numerator. Okay, now we go back the other way in numbers 10 through 15. We're going to take things that are already expanded, and you can see that they have plus and minus signs, the way all of our answers in numbers 1 through 9 ended up looking. And we're going to bring it back into a single logarithmic. This is called condensing the logarithmic expression. In these problems, if you can simplify once you condense, then do so. Okay, so here we go. If it's a sum, that means that it used to be a product before it was expanded like this. So when you put this back together, you're going to make these individual augments into a product. So it'll be 15 times x. And that's just because we always write the number first, even though that was the second term. Now you don't need to write the base. We know that the base is e because that's the only base a natural log can have. So that's it. Pretty simple section. Okay, and number 11, you see a minus sign. That means that this used to be a quotient. So you're going to put this back together as a quotient. Remember, anything that comes after the minus sign belongs in the denominator, whereas the positive terms means that they are part of the numerator. So we're condensing this into a single log. You should not see the word log more than once, whether it be natural or common log or whatever the log is. This is log base 6, so it's not a common log. You should only see the log one time. So it's numerator over denominator. Write this better. It's log of 48 over 8. You only need to write that base one time. Okay, and then you see that you can simplify because you have this quotient, and that could be simplified further. 48 divided by 8 is 6 with a base of 6. And you can even go further. You're expected to go as far as possible because my math lab will mark it wrong if you don't go all the way to the most simplified version of the answer. Okay, when this augment matches the base, then this entire expression is equal to whatever this power is. So in the end, this answer is 1. Okay, that takes that out, taking the log with it, and that is the inverse property that keeps being used over and over again in most of these problems. So again, very important property. Number 12. Okay, we're looking at a minus sign. That means this used to be a quotient. What comes before the minus sign is the numerator. What comes after the minus sign belongs in the denominator. So this is single log. Here's your numerator. I'll write this a little closer. For x plus 1 divided by x. And on a log where there is no base, the base is said to be a 10. This is a common log, base 10. You can put this in parentheses just because it has two parts. It has a numerator and a denominator. So that's your finished answer. Just recognizing what do you bring it together as, a product or a sum. Okay, then as we move to the next one, you see that in this one, you have a product because there's a plus sign. Products indicate that you used to have a plus sign. You also have a 9. And if this is a coefficient, that means it really used to be the power that belongs there. Okay, so you're going to write single log. We're going to make a product of y times this z term, but bring that power back up. So we actually use the product rule and also the power rule as we condense this into a single log. Okay, moving to number 14. Okay, we're dealing with a quotient here. Only there are coefficients in front of both of these logs, so those need to be brought back up into the power position while creating the quotient. This is going to come right back up here. So we're going to do single log. We're going to do our quotient. This would be in the top of the quotient. This would be the denominator of the quotient. So in the top of the quotient, it's going to be x plus 9 to the second degree, because that coefficient needs to swing back up and become the exponent that it was before it got expanded. This is it in its expanded form. So x plus 9. A little square up here, that's the numerator, and then what comes after the minus sign is the denominator, and that would be x. You don't write ln again, you're just writing a single log. Swing that 9 back up into the power position. And there we go. Okay, so it's ln of x plus 9 squared over x to the 9th. And you don't have to write the base there because that only has, it can only be an e. Okay, here you have 3 terms. Remember, what comes after the minus sign, that's the denominator. Anything that comes before it, this is all the numerator. This is the numerator in your quotient. This is the denominator. Okay, so this is going to be, and then you see all of these numbers that are out in front of the word log, they're just the powers that belong to those augments. This is really going to be x to the 6th. This is really going to be y to the 3rd. And this is really going to be z to the 4th. Okay, we're going to put together that quotient now. So it's ln. We know that in the denominator there is a z to the 4th. And in the numerator we have a product. The reason that we have a product is because what joins these two terms is a plus sign. So that means these were a product in the numerator. So it's going to be x to the 6th times y to the 3rd. Oops, did that backwards. X to the 6th, the 6 goes right on top of this x, and y to the 3rd. Okay, so that covers pretty much everything that you're going to see in my math lab, and that is it for section 4.3. See you again for section 4.4.